You must have heard about queue data structure, but you might be wondering where do we use it in software development? Hi, my name is Prateek, and in this tutorial we'll be looking at the fundamentals of queue and its applications such as message queues, rate limiting algorithms, and much more. But before we move on, make sure you check out free masterclasses on Scalar's event page by industry leading experts. The link is in the description below. Also, subscribe the channel if you haven't already. Let's start with the video. So let us start by understanding the fundamentals of a queue. What is a queue? A queue is just like a real life queue. So in most general terms, a queue represents a sequence of objects waiting to be served in a sequential order. Okay. So one thing you need to remember is queue is also a linear data structure. Like other linear data structures you have seen so far, arrays, array lists, tags, linked list. Queue is also a linear data structure that stores the data in the sequential order, starting from the beginning of the queue, right? For example, if you go to a bank, right? So the person who enters the queue first, it is at the front of the queue. Second person is behind it. Third person is behind the second person, and so on, right? So in general, queue has two ends. One is called as front, from where the people will be served, right? And one is the rear end from where people will join the queue, right? Basically, insertion of data will happen from this side and removal of data will happen from the front side, right? People at the front, once they are served, they will get removed from the queue, right? Now this queue can also be seen as queue of cars at a toll booth, right? People standing in a line to buy tickets, right? And in the world of computer science, we use queues a lot, right? For example, many people are uploading videos on YouTube, and YouTube has maintained a queue so that people who have uploaded videos first, their videos will be processed, right? So we might maintain a queue of videos on the server waiting to be processed, right? Similarly, on in software applications, for example, an application has to perform several tasks. It might maintain a queue of the task that it needs to perform so that our work gets done, right? So queue is again a very important, very interesting data structure, right? So now let us talk a little bit more about the operations. So as I discussed, one fundamental operation on the queue is insertion, right? I want to insert something into the queue, right? So the kind of queue that we are discussing current now, it is called as FIFO queue, first in first out queue. Why? Because the person who joins the queue first is the first one to get served, right? So in a FIFO queue, insertion happens at the rear end of the queue. So this is your, let's say, rear end, right? Whereas deletion happens at the front end of the queue. So this is your front side, right? So anything, you cannot say, okay, I want to remove something from the middle of the queue. That is not possible. Only the data which is at the front of the queue will be removed, right? There is one more operation. So we have seen insertion, we have seen deletion, right? We will discuss how these operations are implemented using other data structures, right? There is one more operation that is called peek. So I want to look what is the uh, front element, okay, who is standing at the front. We call that operation as peek. So just in case of stack, if you remember, the peek operation returns the top element of the stack. In a queue, peek operation should return the front element of the queue, right? The person who is standing at the front of the queue. So that is what peek operation will do, right? So as a next step, we will look at the implementation of a FIFO queue, right? So there are three common ways to implement a queue. We can use a fixed size array, right? And we'll see how this array will behave as a circular array when we are going to implement it. Okay. So in this case, queue will have a limited capacity because the array size is fixed. Suppose n is 6. So I cannot have more than 6 elements in this queue at any given point, right? Second is I can use a dynamic array. So I can write my own logic for creating a dynamic array. For example, if my queue gets full, I will say fine, I will double the array. I will create a new array of double the capacity of the given size, right? Now, if again the queue gets full, I'll again do the same thing, right? So this is called as implementation using a dynamic array. The other option is if you do not want to write the functionality of doubling, it is already implemented inside your array list class. You can also implement queue using a array list, right? Third is we can build a queue using linked list as well, right? linked list is a dynamic data structure. So we will look at how a linked list can be used to implement a queue as well, right? So let us start with the first implementation, that is implementing a queue using fixed size array. Now let us talk about how we can implement operations on a queue using a fixed size array. So the three operations that we need to build are enqueue, dequeue, and peek. So enqueue means I want to insert something into the queue. Dequeue means I want to remove the element at the front, and peek means I want to get the element at the front. These are the three things that we will have in a FIFO queue, first in, first out, right? Now let's see how we can use a fixed size array to create these operations on the queue, right? So in the beginning, I should know if something is coming at what index I will insert it into the queue, and at what index I will remove it from the queue, right? So what I will do, I'll say, okay, let us take a variable called front, and it is here, right? We can also take another variable rear, but again, that is optional if we are maintaining the size of the queue. In the beginning, size is 0, front is also at 0. That means nothing is inserted in the queue yet, right? Now someone says, okay, person 1 is going to join the queue and I will insert it, right? What I will do, I will insert it at the rear end. Okay, so how do I compute the rear end? Let's see. The rear end can be said as front plus size. I will tell you why, right? So what is front? Front is 0. So what is size? Size is 0. So 0 plus 0 is 0. So I can insert person 1 here in the queue, right? And I will increment the size. The size will become 1, right? Size is going to become 1, right? So I'm not going to change the front. Look carefully. I'm not going to change the front, right? Now it was 0 plus 0. That's fine, right? Now I can say again, I want to insert person 2. Okay, I want to insert person 2. At what index I will insert? I will insert it at the rear end, right? So what will be the rear what will be the rear value now? It will be f plus size. So f is 0, fine. Size is 1. It is going to be 1. So I can insert person 2 at this index. Very good, right? Now let's say one more person wants to join the queue. So I want to insert person 3, right? Size is already 2, right? I've inserted 2 elements. But what index I will insert? I will insert it at the rear index. What will be the rear index? 0 plus 2, that is going to be 2. That means person 3 will be inserted here, and this is the new rear. Okay, so front is not changing, rear is changing in this case. Again, I want to insert person 4. Let's insert person 4. So size is already 3 now, right? Size is already 3. So what will be the new index? 0 plus 3, it's going to be 3. I can insert person 4 at this index, and my rear is already here, right? Now suppose I've done a lot of insertions, I want to remove something, right? So I have inserted till person 4 also, and I want to see how my front is going to change, right? Now suppose I want to remove something, I want to perform dequeue, right? So that means I got a query to remove the front element. The front element will get removed, right? Now how do I remove it? If I move this f one step forward, right, and I will have to reduce the size. So right now the size was 4 because 4 elements are there in the queue, right? My size becomes 4. From 4 it becomes 3, and I say okay, f should move one step ahead. So I'll say okay, I'll take this front one step ahead. That means this p1 is it's kind of a removed, it's not there, right? So the area between front and rear, it is the content of the queue, right? Now suppose I want to insert something more, right? So what I will do, I'll again do front, which is at 1, okay, plus size, which is at 3. So look carefully. So 1 plus 3, I get an index 4. That means the next insertion will happen at this index. Can I insert something? Of course I can insert something because queue is not yet full. I insert something at this index, right? Now suppose I want to do one more insertion. Again, what is the value of size now? Size is still 4. Size is 4, right? So what will be the value of rear? So it will be front, which is 1, plus rear, which is at which is plus size, which is 4, right? It is going to get 5. Now is this 5 a valid index? Is this 5 a valid index? The answer is no, right? Now I will get a problem that if it will give me index out of bounds exception, but queue is not yet full. Queue is not yet full. So how should I handle this case, right? The way to handle this case is by treating this array as a circular array, right? If you exceed 4, you should come back to this index. You should kind of rotate, and you should come back here, right? Now how do I achieve this? I have to say take a mod with 5. Every time you hit a 5, you go back to 0 again. You start filling the queue from this index. Now suppose I got this p5 I have already got. I want to insert p6, right? This p6 will get inserted here, right? What I'm saying is the rear will not be updated using this formula. The rear will be updated by using front plus size mod of the capacity of the queue. The capacity is 5, right? So I have to take a mod with capacity. So that means if you hit the capacity, if the rear index hits its capacity, it will be again shifted back to 0, provided your queue is not full. You have to check that, okay, if my size is 5 and I have only 4 elements, right, then I can add more. The size is 5 and I have already added, if the capacity is 5 and the size is also 5, in that case I will throw that the queue is full. I cannot insert anything more, right? So I will insert it here, right? Now my front is still at p2, right? Front is still at p2, but my rear is here, right? Now someone says, okay, I want to remove something, or let's say I want to insert something, right? Now what is the size? The size is 5. Can I insert something more? The answer is no, right? So what you will check, that if your size is equal to the maximum capacity that we have allocated, I cannot insert anything into the queue. So I have to throw some kind of error that queue is full, right? Now again, let's say I want to insert, perform the remove operation, right? So how I will do it? I'll say fine, I'll move this front from here to here. I will reduce down the size from 5 to 4, and this makes that p2 is not there, right? So p2 is not there. I'll either make it 0 or I'll just keep it like this, right? Now I can insert something, right? I want to insert something. So what is my front? Front is at 2. What is my rear? Oh, sorry, what is my size? The size is 5. So 2 plus 5 mod 5, it gives me 2. Oh sorry, the size is actually 4. The size is 4. So 2 plus 4, that is 6 mod 5, it gives me 1. 2 plus 4 mod 5, it's 1. That means the rear should come here, and the next insertion will happen at this index. So if p7 comes, that person 7 will be stored at this place. Again, if you want to remove something, you will remove from the front. So the front is p3. So you will read the elements in this order, right? The elements will be removed in this order, right? One thing you have to notice when you're moving your front, right? So your front will also go like this. It will go to p3, p4, p5, and again it should come here, p6, p7, right? Basically what I'm trying to say is that when you're doing this operation, that front will move like f equal to f plus 1, right? Here also we should do mod with the capacity, so that my both front and rear move in a circular fashion inside the array, right? At any given point, right, I have to check if the queue is full, I cannot insert something. If the queue is empty, I cannot remove something, right? So we have to handle two cases, that if size equal to maximum capacity, I cannot insert, and if the size is 0, I cannot remove, right? So these will become our special cases in the code, right? I cannot remove. So I hope you understood the logic for the fixed size queue, and now we will jump into the implementation. Let us start implementing queue using a fixed size array. I will be using Java, but you can use any language of your choice for the implementation. So let's begin. The first thing I will need to do is I need to create a class queue, and I need to define few data members. So as we have discussed earlier, that if we are using a fixed size array, we will need a object reference to store this array, right? So you can call it anything. I am just going to call it as ARR, right? So let's create this variable data member. So I'll say private, it's an integer array, and I need to define what is the maximum capacity of this queue, right? So that I will define using a constant because I'm taking a fixed size array. I'll say okay fine, this constant will be a public static final int called as default capacity, and this is equal to 10, right? One thing I need to notice that if someone is inserting data into this queue, what is the current size of the queue? So I'll take another private variable to denote the size of the queue, right? And now in order to perform operations like insertion and deletion, I must know the front of the queue. So I'll create another variable that is private int and I call it as front, right? These are the four data members that we will need. So one is your capacity, let's say that is 10. Then there is your front, which is initially at 0, and there is size which will be also at 0, right? Now we need to initialize these data members. So that part we will do in the constructor for the queue, right? So I'll say fine, let's create a constructor, and in this constructor I'm going to create a queue, right? So maybe I'm going to get some capacity as input, right? If nothing is given, I will use the default capacity. So I'll create actually two constructors. One is the parameterized accepting capacity, and other one does not accept any capacity from the user. So in this case we will use the default capacity. So one thing we can do is from this constructor we can directly call this, and we can say okay fine, you can call this constructor and give default capacity as a parameter to it, right? So that will help me to avoid creating an array here, and that part I can do directly here, right? Let's see how we can do it. Now if my capacity is less than 1, if someone gives a wrong argument, maybe a negative capacity, in that case my code should throw an exception. So I can say throw new exception that invalid capacity you are giving it to me, right? And also we need to define that this throws an exception, right? All right, now let's do the actual work. So actual work is that we need to initialize this array, right? So I need to say that fine, this array that I have, right? So again I'm using this which is optional here, but it's a good thing to do because you are clearly referring to the data member of the class. So this dot array should be a new array of capacity, right? Now this capacity can come as an argument from the user directly, or if the user does not give, then this constructor will be called and this capacity will come from here, right? That will be your 10, right? And here also we need to say that this method can also throw an exception. So this is how we have initialized our array. Now we need to initialize the size and the front variables. Initializing them is pretty easy. So I can say this dot size, it is 0, and this dot front, that is also 0, right? So I hope this is clear. So we have created a new queue of given capacity. It can be fixed size, it can be given by the user as well, right? So we have a capacity, right? Let's say capacity in this case is 1 2 3 4 5 6. So capacity is 6, front is 0, array is referring here, and the current size of the queue is also 0. So the queue has been initialized correctly. Now the next operation that we need to build on this queue is Enqueue. I want to push something into it. So I can say public void Enqueue, and I'm going to get some data or value to add into this queue. Now since it is a fixed size queue and it is possible that queue is already full, so how do I check if the queue is full? I can simply say that fine, if the current size, if this dot size, that is my data member, it is equal to the capacity of the queue. So what is the capacity? This dot array dot length, right? Length of the given array. Then I can say throw new exception that my queue is, and here I can say that this method also throws a exception. But if the queue is not full, so we can insert it, right? So if the queue is not full, we can say okay fine, we will push something at a rear index. So we will need to compute that rear index. Let's see how we can compute that. So I can say the rear index according to the formula is the front index plus the size and then we have to take the mod with the capacity. So that capacity is nothing but this dot array dot length. That is the capacity. Now in this case, rear will be 0 plus 0 mod with 6. In that case, it will be 0. So I will insert something here. And then again, size will also increment. So we will put the data. So we'll say this dot array at the rear index. I want to put the value. I'm storing 1 and I need to update the size. I need to say the size is now 1. So next time the rear would be 0 plus 1 mod 6. Next time the insertion will happen here. So maybe I push 2. Right? So I'll do the insertion at this index. So in order to achieve that, I have to say this dot size plus plus. So I need to increment the size as well. So that's how the Enqueue operation will work, right? And finally, you insert here, you insert here, you insert here, you insert here. Now if you try to insert, the queue is full. You have to remove something. So maybe this gets removed. So your F will come here, right? Now let us look at the remove method as well. So in that case, we can call the method as public. Now either you can make it as void or you can make it as int. So you also want to return what has been extracted from the queue, right? So in that case, you can make the return type as int. Now this method can also throw an exception. If your size is 0, that means queue is empty. You cannot remove anything from this queue. If this dot size is 0, what you should do, you will say, okay, throw new exception that queue is empty. But if this is not the case, I can say throws new exception here. Sorry, throws exception. But if this is not the case, what we discussed, what we will do, right? So we'll store maybe this data 1. We'll store this 1 here. We can say, okay, our output, the answer that we want to return is present at this dot array of front, right? Or this dot front, whatever, right? So you can definitely return this answer, but you have to update your front and you have to update your size as well, right? So I can say fine, this dot front will move this dot front equal to this dot front plus 1 mod capacity. So capacity is this dot array dot length, right? And the size will reduce this dot size minus 1. If you remember from the diagram, this is what we discussed earlier also, that this is how my front will change in case of removal, right? Okay, and this is how I will compute rear, right, in the case of insertion, right? We have already discussed how it's going to work. So I'm changing the front and I'm changing the size as well. So this is my DQ method, right? Now let us write some more methods that would be helpful. So one method would be peek. If I want to look at the front element, I can say fine public int peek. Now if again the queue is empty, I cannot look at the front element. So if this dot size is 0, I can say fine throw new exception, the queue is empty. Queue is empty. That means I cannot remove anything from this queue. Otherwise, okay, let's just fix the error. Otherwise, I can say return the front element, this dot array of the index, which is this dot front. Okay, that is my peek method, return the front element. So the complexity of this method would be order 1. Here also, DQ method, it will be also order 1. The insert method, that is also going to be order 1. The constructors are also order 1. Apart from it, we can make 2-3 more methods. One is to check if the queue is empty or not. That can be a boolean method. I can say public boolean is empty or just empty, right? So I can return true if this dot size is equal to 0. I can make a method called public boolean full. So I can return if this dot size equals this dot array dot length. Okay, that will tell me if the queue is full What else? I can also make a method to get the size, public int size. I can return this dot size from this method. Anything else that you think would be helpful? Maybe just a method to print the entire queue, right? So maybe I want to display the entire queue, right? So in Java, this method is called as toString, which is present in the default class. So I need a way to look at all the elements of the queue, right? So right now I'm not going to iterate from front to rear. I will just display the array. So it's more of a method for debugging, not for doing anything else. Okay, I'm just going to print my array, or we can say we can print. So one simple way you can do it: sout arrays dot toString, and you can say this dot arr, right? But now instead of doing this, you can also say that fine, I would print elements from rear to front. Suppose this diagram is your queue. So maybe I want to print the elements from rear to front, right? Or front to rear. So how I can do it, right? Now suppose if my front is at 2, right? So I want to print, let's say 1, 2, 3, 4, 5, 6. So I want to print all the elements from front to rear of the queue. I want to display all these elements. So my output should be 1, 2, 3, 4, 5, 6. So how I can do it? Very easy. I know this index. I can compute this. I can compute this. I can compute this. So this is f plus 0. This is f plus 1. This is f plus 2. This is f plus 3. This is f plus 4, right? And of course you have to take the mod so that you can rotate in this circular fashion. So very easy. I can say for int I equal to 0, I less than this dot size. Okay, and I can say, okay, the current element, the current index will be nothing but this dot front plus I, take a mod with this dot capacity, that is array dot length. Now I can say sout that element. So this dot array of index followed by a comma and sout. This looks good to go. This will print all the elements from front to rear. Now let us test our functionality in the queue test file. So we have created a queue test. So here what we need to do, we need to create a queue, right? So we'll say psvm, that is the main method. Now we can create a queue object, queue equal to new queue. Let's say the capacity is 5. Now I want to add certain elements to it, right? Throws exception, right? We have to tell that main can also throw an exception here. Now capacity is 5. So what do? I say, okay, fine. Let's push queue.enqueue1. Let's say 2, 3, 4, 5. Then I remove something. Let's say queue.dequeue, queue.dequeue, and then I can say 7 and 8, and then I can say queue.display, right? Now let's see how this queue should look like. Let's go and run the code. So I inserted 1, 2, 3, 4, 5. So the queue was full. Then I removed something, right? So I removed this. I removed this. My front is here. And then I enqueued 7 and 8. So 7 and 8, they will come here, right? So if I now print my queue, it should be like this: 3, 4, 5 and 7, 8. Yes, that is what I'm getting, right? That means my queue is behaving in a correct manner. The front element would be this, next front 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 would be this. So I hope you understood the implementation of queue using a fixed size array. Next, we will jump into the dynamic array implementation of the queue. So let us now discuss the implementation of a dynamic queue, right? Now there are two ways. One, you can use a linked list, or you can use a dynamic array as well, right? So in this implementation, I'm going to show you how we can use a dynamic array functionality and we are going to extend the implementation of the queue class by adding this functionality. Okay, so queue we have already written. What I'm going to do, I'm going to create a class called dynamic queue, which will be the child class of the parent class. So dynamic queue extends the queue class, right? Now one thing to notice that this dynamic queue, it's going to behave in a similar way. The operations enqueue, dequeue, peak, they will remain same. The only thing is the logic in the insertion operation, that is enqueue operation, it's going to change, right? So first of all, let us start by creating the constructors for this class. So I can say public dynamic queue. So again, there can be two types of constructors, one without the capacity and one with the capacity, right? So public dynamic queue, where I'm going to accept some capacity, right? Now in this case, in the first constructor, what I'm going to do, I'm going to simply call the second constructor with default capacity. So I can say this and call it with the default capacity. Basically what is happening, if I want to create a dynamic queue object in which I'm not getting any capacity, so I make a call here. If I get a call here, right, again what I can do, I already know how to create an array of given capacity, that I'm doing in the parent class, right? So queue is my parent class, dynamic queue is my child class. So if I want to create a fixed size array in both, so if I get a call here to create a dynamic queue, I can redirect the call to the parent constructor. So I can say super, and I can pass in the given capacity that I am getting, right? Basically I'm calling the constructor of the parent class, right? Now this is a spelling mistake, dynamic queue. Now the parent class constructor, if we look carefully here, right? So basically what is happening, the call is going to come here to this constructor. So we are already initializing the array correctly, size is set to 0, front is set to 0, and we are also throwing a exception. We can also say that our dynamic queue can also throw an exception. This can also throw an exception. Now the errors are resolved, right? So constructor part is done. Now there won't be any change in other methods except enqueue. Let us see. So if I want to enqueue something, let's say public void enqueue. So I'm going to override the method that I have written for insertion. You can see we are overriding this method, right? Now there are two things we have to do. We have to expand the array, right? And then we have to put the element if the queue is full. Okay, put the element, right? Expand if queue is full, and then we have to put the element, right? Now this functionality we were not doing in the previous implementation. Now we have to do this functionality, right? Now assume that your queue looks like this. So suppose queue is like this, 1 2 3 4 5 6, right? And suppose my front is here. That means if I want to read data, I will read the data in this manner, right? So my capacity was 6, size is also 6. That means my queue is full, right? And I want to create a new queue, a new array basically, with double the capacity, right? Let's just say that this is going to be 2x, twice of the original capacity. Now if I want to copy this data, can I copy it directly? Can I say I'll copy 5 6 1 2 3 4? Will that be correct? The answer is no. Why? Because if I want to do a next insertion, right? So at what index the next insertion happens? It happens at front plus size, right? So in this case, front is at 2, fine. Size is 6. The next insertion will happen at the 8th index. That means I will start filling from this index. But is it correct? The answer is no, right? Because what happens at these places we don't know, right? So the correct way of doing the copy is you create a queue of double the capacity, right? You iterate over this part. Let me change the color. You iterate over this part in a circular way, and you copy the elements here, right? So you copy 1 2 3 4 Then you copy 5, 6. This is my front. This is my front. Now if I want to do an insertion, so my rear would be front plus size. Front is 0. Fine. Size is 6. I'll start copying from the 6th index. 0, 1, 2, 3, 4, 5, 6. That is correct. So if I want to push something, that insertion should happen at these places, right? So let's see how we can do this, right? So let's say this is my original array. This is my temp array in which I'm going to perform a copy. So I will say if what, how do I check the size? If this dot size is equal to this dot array dot length, right? Now one thing you will notice that these members were earlier private. So I've just made them protected now, right? I've made them protected so that I can use them in the child class, right? So coming back here, so I can access the data members of the parent class because they are now protected, right? So what I have to do, I have to create a new array of double size, right? So let's say there is a new array called temp that is equal to new int of size twice of this dot array dot length. So this is created. Now I have to copy the data. So I can say for int I equal to 0, I less than this dot array dot length. That is the size, right? Or you can say this dot size. Both of them, they are equal. I plus plus. Right? I'm going to run a loop these many times, right? Okay, so I'm going to iterate over these positions. 7, 8 will come later, right? I need to copy these values, right? So I can say temp of I at the ith index in the temp. What should I copy? So at this index, what should I copy? I should copy the element from the front. So this is f plus 0. Then at the next index, I should copy this LU. This is f plus 1. Then this is f plus 2, f plus 3, f plus 4, f plus 5, and so on, right? So I can say this is going to be equal to this dot array of, let's find the old index. So this is going to be this dot original front plus the original size with the original capacity mod, right? So the elements at the at this particular index, right? Mod this dot array dot length. This is what I need to do, right? Sorry, this dot front plus this dot plus I. Sorry, that's a mistake. So f plus 0, f plus 1, f plus 2, f plus 3, right? So basically the ith element. Okay, so the element at, let's say, temp of 3 will be equal to array of f, which was, let's say, 0, 1, 2 plus I is 3 mod 6. So it will be array of 5. So fifth index 0, 1, 2, 3, 4, 5. So that element is 4. That's correct. So at the third position, I'm putting the value that is 4, right? Array of 5. This is what I need to do, right? So just like we did in the display method in the queue, that is the same logic we are using here, right? Once this is done, temp array has been created, right? So I've erased all of it. I'll just do it once again. It was like 1, 2, 3, 4, 5, 6, right? This is my front. Now I've copied this data like this. 1, 2, 3, 4, 5, 6. So I have to reset the front here, right? This should be the new front. Okay. And this was my array. This was my temp, right? One thing I need to change is that this ARR should refer to this memory. This connection should get broken. So I can say this dot ARR. This will be now referring to temp object. And now doing this, no one is referring to this memory. So garbage collector will clean up this memory, right? And this dot front will be set to 0, right? But have I really done insertion as of now? The answer is no. We have still not done the insertion part, right? So how do I insert? I can say fine, at this position, which is rear is my f plus size mod capacity. I will do array of rear equal to the value that I'm inserting, and I will do size plus plus, right? Now this code I'm already doing in the Enqueue method of the parent class. So I can just call that method super.enqueue and I can give value, right? Now this method will get to know that the array has been changed because ARR is now referring to this memory, right? And it will try to push something into this method, right? Something into the new array because we have changed ARR, which is now referring to the new array, right? So I can say this method can also throw an exception, throws exception. This error should get resolved. Let us look at the Enqueue method of the parent class. So here what is happening? This is what we are doing, right? Now this condition is handled in the child class. If queue is full, double it. When you come back into the parent method, this condition will not be true. So what code will execute? This code will execute, right? That is how we have implemented dynamic queue using a dynamic array, right? Now let us test our functionality. Let us go back into queue_test.java, right? So earlier I was creating a queue of fixed size. So if I try to let's say push 6 elements in a queue of size 5, I will get a exception, right? I'm using the fixed size queue. Let's see. So I'm getting an exception that queue is full, right? Now if I replace this queue object with the dynamic queue object, let me show you. If I do this, I should be able to hold it, right? Yes, I'm able to hold it. I do not get any exception because queue is getting expanded, right? And even I can put more elements. I can say fine, let me put 9, 10, 11, 12, right? And so on. So let's see what output do we really get. I'm getting everything from 3 to 12, which is correct, right? So you inserted 1, 2, 3, 4, 5, 6. Then you removed 1, 2, the elements at the front. Then you inserted 7, 8, 9, 10, 11, 12. Okay. Irrespective of the initial capacity, which was 5, you are able to hold more elements because your array is getting expanded during the insertion process, right? So in this case, you will never get a queue is full exception unless you run out of your heap memory or something like that, right? So that is dynamic queue using a dynamic array, right? So next we will discuss dynamic queue using a linked list. So far we have seen two implementation, fixed size array implementation and dynamic array implementation we have seen, right? You can also use a array list object if you want, right? Now third kind of implementation will involve a linked list because linked list is also a linear data structure, right? Now you might ask how we can use a linked list. It's pretty simple and very intuitive as well. Now suppose you are inserting something. So 1 is at the beginning, then you insert 2, then you insert 3, then you insert 4, right? Now if I ask you, this is let's say head and this is tail, right? If I ask you where is the front element, right? So I want to get the front element, so that is 1. If I want to remove this element, can you remove it? Of course yes, you can say okay, I will move this head here and that means this element will be removed. If I want to read the front element, again that element is present at the head of the linked list. If I want to insert something, it should go at the rear end. So where is the rear end? The rear end is at the tail, right? So you can easily insert something here and your tail will come here, right? So your head and tail data members will behave as front and rear for the linked list. So this will be your front, this will be your rear. You can always insert at the rear end, which is insertion at tail, and it will be a order 1 operation. And you can always remove from the front end, which is again going to be a order 1 operation, right? So very simple implementation, and we have already covered linked list. So I will not write the code using linked list. Once again, you can either use the same class object. So in your queue class, you can say fine, I'm going to create a linked list object, linked list L, and whenever you want to enqueue, you add it to the linked list, and whenever you want to remove, you remove the first element of the linked list. Okay, so those methods can be implemented, or you can implement all those methods from scratch as well, right? So that is about implementation using a linked list. Now, before we wind up this tutorial, I want to talk a little bit about the Java queue that is part of collections framework, right? So the Java queue supports three types of operations. So one is your insert, remove, and examine, right? So examine is like getting the front element, right? Now there are two variants of the methods that are provided. So in one variant, the methods throws an exception, like the variant that we have coded. Those methods throw an exception. So if you want to add something, the method is called as add instead of enqueue, right? So you will say, okay, I will create a queue object and I will call the library method add, right? If I want to remove the front element, the method is called as remove instead of dequeue. And if you want to get the front element, it is called as element, right? If the queue is empty, it will throw an exception, right? And the second set of methods, they are also same, but instead of throwing an exception, they will return a special value, maybe a boolean value, whether the operation was successful or not, right? So add and offer, they are equivalent methods. Remove and poll, they are equivalent methods. Element and peek, they are equivalent methods. Okay, so I've discussed about queue interface in my Java collections tutorial on the channel, right? So what we talked about is that in Java, queue is actually an interface, okay? And there are three implementations. There are three classes that implement this queue. So your linked list class, it implements your FIFO queue that we have just seen, that we can build a queue using a linked list, okay? And there is a class called as array-deck. So array-deck is a class that implements another kind of queue in which you can insert and remove from both ends, right? So it is called as a doubly ended queue. So in this case, the behavior would be different. You can add at first position, you can add at last position, you can remove at first position, you can also remove at last position. So it is a doubly ended queue. It's called as deck, right? It's not dequeue, it's called as deck, right? It's a different type of queue. And third type of queue, it's called as a priority queue, which we will of course discuss. It is based upon the concept of heap data structure. In this case, the elements don't maintain a FIFO ordering, but they maintain a priority ordering. So again, it's a big topic. We will discuss it separately. But if you want to see the code demo, how these different queues are, how these classes are different in behavior, check out my video on data structures, and in which I have discussed the complete collections framework as well as different implementations of queue as a part of that video. So that's all for today's video. I really hope you were able to understand queue and its applications really well. But before you leave, make sure you like this video, share it with your friends, subscribe the channel, and also don't forget to press the bell icon so that you never miss an update from us. I'll see you next time.